Welcome back. In today's lesson, we will start a brand new project. In the next few lessons, we will explore variables of different data types in more detail. We will learn how to manipulate and process variables. In this lesson, we start off with string variables. This is Unit 10.5, the first of a 4-part lesson, where we will learn about Delphi's built-in functions to work with strings. In the new demo, we will explore the following functions: length, concat, uppercase and lowercase, trim, copy, pass, insert, and string replace. In our project, I will show you how to pop up a dialog box with the InputBox function. An input box can get input from a user that can also be stored in a string variable. Like I said, these functions will be explained in a series of tutorials, so we will only learn about a few string functions every time. But let me first show you how we will use these string functions in a project. This is the new program. I already have code in this example, but with every function that we will use, I will rewrite the code and explain it to you. This project accepts a phrase from the user in this edit here. To avoid typing a phrase every time, we will write code in the button's click event handler to retrieve a pangram and display it in the text of the edit. A pangram is a phrase that contains every single letter in the alphabet. Here I have 2 panels to display headers, and next to the headers I have 2 more panels. Our code must count the characters in this phrase and display the result in the first blank panel every time the user clicks on any one of these buttons. We also want to show the user additional messages in the blank panel here at the bottom every time the user clicks a button. When clicking the display pangram button, the text shows in the edit. It reads, "The quick brown fox jumps over the lazy dog." This phrase contains every letter in the alphabet. Here we show the length of the phrase. It shows the text. The phrase has 45 letters. And here we see an additional message that reads, "Default phrase loaded in the speed of light," and between brackets we show the actual speed of light in meters per second. You will see why we do that later. The uppercase button formats the phrase to uppercase characters, but it also refreshes these outputs for the length and the message panel. In this panel we display a new message that reads, "You formatted the phrase to uppercase letters." The lowercase button must format the phrase to lowercase and refresh the message again, like this. The default phrase has 45 letters, but that includes a space here in the front and another space here in the back of the phrase. The trim function removes the leading and trailing spaces, like this. And in this message, the length changed from 45 to 43. And this message also changed. You already learned how to use uppercase, lowercase and the copy function in Unit 8.10, but I'll show it again in this series. The copy button will ask the user to provide the value to be copied. This is done with an input dialog box that is also created with a function. The default value is dark, but the user can type any word that already exists in the phrase. I will type lazy and click OK, and this message shows what word was copied in quotation marks. The insert button pops up another input box that prompts the user for the word that must be inserted. In my code, I programmed that the insert must squeeze the input in before the word fox. So here I must use the pass function to determine the position before I insert a new value. Here the default value in the input box is sly. I will leave it like that and click OK. Our new word now includes the word sly between brown and fox. These 2 outputs also changed. The length is now 47 letters, and here we see that the new word was squeezed in at position 17 of this phrase. The string replace button pops up another input box to get the word the user wants to replace. The word dark is the default. I will leave it like that and click OK. Then a second input box asks the user to enter the replacement value. The word hawk is given as the default, but I will change it to elephant and click OK. Dark is now replaced with elephant, and these 2 inputs were also refreshed. We will only program the first button today. The rest is for the next 3 tutorials. Here's the bad news. You must create the user interface yourself by looking at mine. To save time, I'm not going to create the user interface with you. I will only go through the code with you. But here's the good news. I provide all the projects we use in these tutorials as downloads. Just go over to patreon.com/LearnDelphi and search for the unit. If a download is available for a tutorial, you will find it at the bottom of the lesson. Download the zip and extract the files to a location of your choice. You will find a video folder with this video that you can view offline, and 2 project folders. The starter folder contains the project without any code, so you can open it and start coding with me. The solution folder contains the same project, but it is how your solution should work at the end of the tutorial. If you do run into problems, you can compare your code with the solution. While we are here, just a thumbs up to my patrons on Patreon for your continuous support. Thank you so much, guys. I hope you enjoy the early access to new lessons I publish weekly. Let's now move over to Delphi. This is my project in design time. Like I said, you must observe how I created the user interface and create it yourself. For example, look here at the left in the structure panel for the types of components and the names I assigned to them. It shouldn't be so hard if you learned the naming convention I explained in Unit 7.1 and 7.2. You can also look here at the right hand side of the IDE in the Project Explorer to see how I named my project in unit files. Now let's see what we need this display button to do. It must show the default phrase, that is a pengram. The user can also type in his own phrase, but we will also provide a default phrase with this button. That means the edit named EDT phrase will be an input and an output component. The button must also go count the characters in the phrase and show it here in the panel named P&L length. It must also display an additional message that reads, default phrase loaded in the speed of light, and it must show the exact speed of light in meters per second, between brackets. Here you will learn an additional lesson, but wait for it. Double-click on this button while you are in design time. You are now taken to the button's click event handler. Make space above the begin statement and put your cursor in the blank line. Now this is where we normally declare variables for this procedure. But we can also do another kind of declaration here. It is called a constant. You learned that a variable value can change often at various intervals and events in your program. Unlike a variable, a constant's value always stays the same. We declare constants in the same way as variables, but instead of var, you must use the const keyword. Our default phrase is, the quick brown fox jumps over the lazy dog. Notice the space in the front and the end of the phrase. You must also type that. I include trailing and leading spaces to test the trim function that we will do later. This will always be the default phrase. That's why we make it a constant. The name of this constant will be pengram. Notice that the name is all caps. The general convention for constant names is to type it in uppercase letters only. A constant doesn't need a data type declaration like string or integer, but you must always declare the constant value. In this case, it will be our default phrase. The speed of light is one of the great constants of nature. Here I declare a constant named speed of light, and I assign the exact speed of light to the constant. The lesson here is that a constant can take values of any data type. Here we have an integer. As you can see here, this constant takes a string value, while this constant takes the speed of light, which is an integer number. Declaring constants is a bonus lesson, so let me quickly summarize constants. Constants are declared with a const keyword. A constant's value can't change. The general naming convention for constants is to use all caps. I think you will agree that it is easier to remember the speed of light by its name than it would be to remember that it is 299,792,485 meters per second. Even just saying 300 million would be easier, but it wouldn't be precise. And that's your bonus lesson. We do, however, need to declare variables too. Here I declare 2 strings. str phrase will store the phrase that the user provided in EDT phrase. Remember, although we already declared a constant for this phrase, we also have to declare a variable because the user may also enter his own phrase instead of using our pengram. str message will output a message in the message panel. I also need a byte variable to store the character count of the phrase. Here I declared a byte variable named BTE letter count for that purpose. Now go between the begin and end statements. Type these 2 lines of code. When the program starts, the edit is blank, so we must retrieve the name in the constant named pengram that we declared above, and we then assign it to the text property of EDT phrase. This will now display the default phrase. Now that we have the pengram in the edit, we must save it in a variable. Here I assigned a value in the text property to the string variable named str phrase. Then in this line, we count the letters in the phrase with the length function. Let me explain the length function. The length function is used to return the number of characters in a string. Some functions do not need brackets because they do not require a value as input. The length function do require an input between the brackets. Later in this lesson, you will also see that some functions sometimes require more than one input value. We call these placeholders between brackets input parameters. Here in red letters, I have the length function. Here we pass a string named str phrase as an argument to the length function's input parameter. Now let's assume the value in the string variable is my name, Gerard. When the length function receives my name, it will go and do its work in the background, and that is to go count the letters in my name. When it is done, it assigns that result to a numeric data type. In this case, it is a byte variable named BTE char count. Don't forget, every character will be counted, even spaces, numbers and special characters. Now let's go back to our project. So on this line I take the phrase I got here from the edit and pass it as an argument to the length function's input parameter. The result is then assigned to the byte variable that I declared here, named BTE letter count. In these 2 lines, I display the length in the panel named P&L length and an additional message in the panel named P&L message. Let's look at the first one. Here we use Delphi's Concat function to concatenate a series of strings. Let's look at the Concat function in more detail. The Concat function can take multiple string values as input. Here I only show 3 strings named str phrase 1, 2 and 3. But you can pass as many pieces of strings as you need. For example, I can pass the string argument do, re, mi to the first parameter, and fa, so to the second, and la, ti, do to the third. The concat function will join the 3 phrases, just like we did in earlier lessons with the plus sign. The result is then passed as output and assigned to a string. The number of pieces of strings that you can pass is only limited by the size of your memory. Otherwise, you can concatenate as many pieces of strings as you need, like this. Let's get back to work. This concat function nests another function. Delphi will first execute the inner function. In this case, it is the IntToStr function that must convert the number 300 million, give or take, in the byte variable we declared above. And we processed it here by counting the characters. And here we convert it to a string before it can be concatenated with other string values. These 3 values will be concatenated to read the phrase has 47 or 45 or whatever number letters. The result will then be displayed in the caption of the panel named P&L length. And here we use the concat function again. But this nested function will be executed first. We get the number in the constant named speed of light, and then we convert it to a string before it can be concatenated with other string values. These 3 values will be concatenated to read default phrase loaded in the speed of light, and the 300 million that is in the constant called speed of light must show between brackets. Notice how I enclose literal brackets that must display with my text in 2 literal phrases. Now let's test our code. Run the application. Click on the display pengram button. Three outputs are given. The constant that you declared displays in the edit. This panel shows the length of the text in the phrase, and this panel just gives us a quirky message to prove that we know how to use constants. Okay, that's 3 string functions for now. Next time we will continue processing string variables with more string functions. You can now make these 2 lines shorter by splitting them over multiple lines, like I explained in the previous lesson. And we will use this application again, so save your work. And if this tutorial was helpful to you, please like this video and subscribe to my channel. Also share my lessons with your friends and foes on social media. Like I said, next time we will continue processing string variables with more string functions. Cheers, see you later.